Welcome to Learning with Light. This video will be on how the equations of uniformly accelerated motion are formed or derived. Suppose a body or object is accelerating uniformly such that the initial velocity is u, final velocity is v in time t, in a particular time, or the initial velocity u accelerates at the rate of a. We have our acceleration. The initial velocity thereby increases by a numerical value of a for each second that it moves. Therefore, the increase in velocity in time t to a final velocity v will be equals to acceleration times time. So we are going to write that increase in velocity, because this is our final velocity and our initial velocity. So the change in velocity, which will be our increase in velocity, now be v minus u will be equals to a multiplied by t. In terms of algebra, this is acceleration times time, and why we have increase in velocity is because we have acceleration, but when we have a decrease in velocity, we have deceleration. So from here, if I try to rearrange my terms or try to make v the subject of formula, this will give me v equals, if I take minus u to the other side, that will be positive u. So there's an invisible plus at, and this is our first equation of motion. Our first equation of motion. We can recall that from our formula of acceleration, a is equals to v minus u over t, just to also prove our first equation of motion, and we have it: a is equals to change in our velocity, and v minus u is the change in velocity over the time taken. And when we cross multiply from here, if we cross multiply, this will be a multiplied by t. We will have the same thing, and it will still result back to our first equation of motion. So it will still give us, so this is another way of looking at it, but we can see that v minus u is our increase in velocity. This whole term is increase in velocity. So for the second equation of motion, is also tagged as the second equation of motion. It's also known as formula for distance moved in a specific direction. Or we can say that formula for displacement in short. So we can tag this as formula for displacement. To derive the second equation of motion, let us consider a body or object moving with uniform acceleration. Its average velocity is equal to half the sum of the initial velocity u and final velocity v. So average velocity is equals to v plus u over 2. And this is a very important formula, so we need to asterisk it for average velocity of a uniformly accelerated motion. So, and we can also recall that average velocity is also equals to displacement over time. And we would replace or represent displacement with an alphabet. Some text uses the alphabet X, but I'm going to be using letter S to represent displacement. And to since we've represented time with letter T initially from the beginning, so I'm going to represent displacement our time with letter T. So I'll rewrite my formula as average velocity is equals to displacement S over T. And since I already know that average velocity is also equals to V plus U over 2, I'm now going to remove average velocity and equate both of these two equation formulas, and this will be V plus U over 2 is equals to S over T. So from here, I'm going to substitute for V, since we can recall that from the first equation of motion, V is equals to U plus AT. So I'll substitute for the value of V in this equation, and when I substitute for that, this will be S over T is equals to, I'll now have U plus AT plus U all over 2. Or what I will do here, I can separate my denominator, but I have to simplify first, and this will be S over T equals to, if I add up like terms in terms of algebra, this will be 2U plus AT all over 2. And solving this, I'll separate my denominator and I'll have S over T is equals to 2U over 2 plus AT over 2. Since this is a single denominator, I can separate it. This is arithmetically correct, and from here I would cancel out my 2's and I'll be left with S over T is equals to U plus AT over 2, and I'll multiply through by T to find S. If I multiply through by T, or I cross multiply, if I multiply through, multiply multiply through by T to find S. So by multiplying through by T to find S, this will be T multiplied by S over T is equals to T multiplied by U plus AT all over 2, and T will cancel out, t cancelling out, and we'll have s left because this will remain 1, and we'll have t opening this bracket, and that will be ut plus at squared all over 2. And to write this in a proper way, this will now be s is equals to ut plus half at squared, and this is the equation second equation of motion.